everybody. Welcome back, Azure Cosmos DB Live TV. I'm your host, Mark Brown. Episode 26. We're going to talk about something brand new to our show that we've never talked about before. And we've got a brand new guest to our show. Theo, how are you?
Hello, I'm good, thanks. How are you, Mark?
I'm good. I'm suffering a little bit from the pollution around here. I don't know why. I don't know. Pollution levels are elevated around here. It's a bit unhealthy, and I'm a little sensitive to it. So I've been kind of coughing a little bit here and there, trying to wade through it. So heard you had a little bit of a cold there the other day. Hopefully you're all doing better, recovering.
Yeah, I think I'm surviving. So yeah, we'll see how we go.
That's all right. That's all right. So we're going to talk about a topic we've never talked about on this show, which is Cassandra API. So for I think most viewers know, we're a multi-model database service. So we support multiple different database APIs. And one of those is Cassandra. You want to talk about, what is Cassandra? Why would I use it? Maybe that's a good place to start.
Yeah, I guess shall I share my
you want to? Why you got some slides to talk about this too?
Yeah.
Hold on. Let's go do some
something
slides.
I threw together.
Okay.
Yeah, so yeah, I guess folks watching, many of you will know what Cassandra is, but some of you might not. So I guess these are the cool bits for me. Cassandra was the backbone of Facebook. That's where it started, and Netflix as well. So those two things alone, I guess, are a pretty cool thing to have in your locker. Has a fairly short learning curve for app devs. CQL, which is the language, is kind of a subset of SQL, I guess, and it's really, its strengths are it's very highly distributed, very linearly scalable. It's very write optimized with fast reads as well. It's very resilient and fault tolerant, and it's really a multi-master system by default. There's really no single point of failure in Cassandra, and in a lot of ways it's kind of similar to Cosmos DB in how it's architected at the back end, except it's really kind of hyper focused for performance and availability, and it's super configurable at the platform level as well. So there's lots that you can do with consistency and replication, both on the write path and the read path as well. So you can really get in, go to town on those aspects. I
wanted to ask some questions if you could go back there.
Yeah.
So Facebook, if I remember correctly, was a heavy MySQL shop, I think, right? So did Cassandra kind of grow out of their frustration with MySQL, or was this something kind of completely different?
Yeah, as the story goes, as I've heard it, they got to a point where they couldn't scale. They got to the scaling limits of MySQL, so they basically built Cassandra. So the Cassandra project started in Facebook. Eventually, they open sourced it and became Apache Cassandra.
Okay.
There
are nodes there. So they run. Cassandra's got a notion of a cluster, and then you've got different nodes, right? And do those nodes all basically, are they copies of the same data within the cluster,
No, they're pieces of it. Very similar to how Cosmos DB works. So you've got copies of the data in different places, depending on your replication factor and so on.
So they've got partitions.
Yeah.
So we have physical partitions of data.
Yeah.
And those roll up into replicas. And then you can have multiple copies of the replicas in a replica set. So their topology is similar. Is that what you're saying?
It's similar. Yeah. The default, by default, or I suppose by recommendation, it would be a replication factor of 3. So we default at 4, but the setup is very similar. The approach to replication is very similar, and consistency is also very similar. What you have is a lot more configurability on the consistency side in Cassandra. Really, that's the main difference.
I see. So yeah, and we've got what we call partition keys. Those are cluster keys. Is that what they call that, or is that
they call it primary keys, which is kind of confusing if you come from the
SQL.
relational world. Yeah. But the combination of a primary key and a clustering key can be a partition key, and also a primary key on its own if you don't have a clustering key. The clustering key is if you want multiple records per partition, if you like. They don't call it that, but the primary key is basically the partition key. Yeah.
I see. Okay. Yeah. Sorry to stop you. There's some things I know about Cassandra, but I've never really gotten hands-on with it, and I've only kind of at arm's length understood kind of their architecture. So
yeah, you probably know most things about it. if you know Cosmos DB, there's a lot of similarities, but it really kind of tilts in that direction on performance and scale, and just really fault tolerance and availability. But then I guess on the other side of that coin, what's maybe not so cool is that it is highly configurable, but it's also complex to maintain. I would say Cosmos DB is pretty obvious. Really, it's a lot easier, and there's not really much of a query engine. You can't do many aggregate operations. It's very, very sort of geared towards atomic things. So SQL API, even SQL API, which is also OLTP focused, but it's a lot richer in what it can do in its query language. And the fault tolerance and the resilience. Maybe this is being a bit picky, but I think it can be a bit too flexible. You can set any replication factor you want, including 1, which means you're not really,
fault tolerant at all.
So it kind of, all bets are off if you're doing that kind of thing. And also when you've got something as configurable as this, and the levels that you can go to, both in the write path and the read path with quorum settings and hinted handoffs and so on, you almost need a PhD in distributed systems to know how to do it properly, you could say. Whereas something like Cosmos DB has these 5 well-defined, I would call them kind of business use case oriented definitions for consistency, right? So it's quite easy to understand when you go through it. Consistent prefix and session consistency and so on. They're easy to understand. You can understand the use cases that they fit, but there isn't anything like that in Cassandra. It's just very kind of low level. So you have to really intimately understand how the platform is working to know whether it's fitting what you're doing. So that I mean, you can look at that one of two ways. You can say it's really configurable and you can thread the needle on things, but you can also say, yeah, you kind of
I looked at the consistency. So we have a doc that maps Cassandra consistency to us, and I don't understand what I'm looking at. It's too confusing for me. So
we spent a lot of time on that, and in the end there aren't actually any exact analogs, but it's helpful to see what the closest analog is, but even there that was simplifying it, to be honest. So if you really were getting into Cassandra, then there's many levels that you can go. And my personal view is you don't, it's quite rare that you need to go to all those levels, but who am I to criticize?
Designed by someone that likes lots of knobs and levers, I guess.
Yeah. Well, I guess Facebook is the kind of
perfect. Actually, I guess it does. It reflects its. The dog looks like its owner, I guess, if you will, right? To use
exactly.
Kind of a weird metaphor, but yeah, interesting.
Yeah.
So I guess that's Cassandra. So yeah, I mean, this tees up. So why us? I mean, I think you kind of spoke to it in that last slide. Almost, right?
Yeah, I mean, I guess most of the viewers will know what Cosmos DB is, at least at a high level. It's a managed service, right? It has a lot of things that you can't get if you just deploy a database like Cassandra in a single tenanted way. You can't do things like auto scale. It's not a multi-tenanted service. You can't do things like serverless. You don't have these guarantees with SLAs and so on and so forth. So, we could talk a long time about all the benefits of Cosmos DB. And then what is Cassandra API? It's pretty obvious. It's a compat layer over Cosmos DB. So what we do is transform requests that meet the wire protocol for Apache Cassandra into what we need at the back end at Cosmos DB, and then we respond with what is expected with the wire protocol. So the application that's designed to work with Cassandra can work with Cosmos DB through the Cassandra API, and we're basically pretending to be Cassandra at the wire protocol level, which means you can just use any of the open source drivers that are out there and talk to Cosmos DB and get all of these back-end platform benefits by just changing a connection string and pointing to a different endpoint. Of course, that does depend on whether we support the feature. And to be honest, we're pretty close actually now to supporting most of the features that you would expect. Let me find the right window here. What you probably want to do if you're watching this and you're thinking about a service like Cassandra API and maybe you're evaluating it, you definitely want to go and look at this doc first. I don't know if we get the link up there. This is our kind of main support doc, and it details everything that we support and don't support in Cassandra API that maps to the features that you would find in Apache Cassandra.
Do we support multiple versions of Cassandra?
We don't. No, we're kind of sticking to the sort of evergreen PaaS concept, if you like. So we support all of the features. Going back to an early version of the protocol. We don't take the same approach as we've done, I guess, in MongoDB. And even in there, like 3.6, for example, contains some 4.0 features, and 4.0 will probably contain some 4.2 features, and so on. So we take it more from a PaaS service, not being tied to releases and things like that, which is why we detail all of the features here that we support. So it's kind of works for whatever version you're looking at. You can look in here and say, what's supported here.
Got it. I got a question from a viewer. Is there a monitoring tool or a way to get replication delay between geo-replicated nodes?
A way to get replication delayed.
Well, you know what? There is the probabilistic bounded staleness.
Yeah.
In our classic, does that work for Cassandra? If you're using Cassandra API, or
at the database level, it works. What I will say is that you can't override the consistency levels in the same way at the client side, or at least if you look at the mapping document, it's a little bit more basic. But at the database level, all of the consistency settings work as you would expect and in the manner described.
And the monitoring of that too, right? It's like, I think PBS, I hate saying this word because it just rolls off the tongue, but probabilistic bounded staleness is the metric for replication latency in Cosmos. And it right now buried in our classic metrics in the portal. And I know it works for SQL API. I'm guessing it works for our other APIs because we're talking about at the data replication layer. This is well below. This is at the storage layer, well below the API layer. So I don't think it depends on which API you're using. But that's
it works. It works in Cassandra API just the same.
Okay.
Yep.
Right. Yeah. Cool. This is quite a. Oh, there you go. That's my. Here, let me go full screen.
Horrible doc that you. Yeah.
My favorite doc there. Like, what is all of these things? I have no idea. Local one, each core, whatever. Local serial, what? So, I mean, we have more than just strong and eventual. We have 5, but we're not. This is way too much. You can a lot of configuration. I think you're right. I think you're spot on the PhD piece of it there. So
my advice is we put this in because we had asks about how does this map to Cassandra. But my advice, if you're looking at this, is honestly just look at our docs on the consistency levels. They're actually a lot easier to understand, and just think about how you would adopt those settings and how they fit to your use cases. That's honestly easier.
Thanks for saying that. I wrote those. And I still, those docs were pretty dense and hard. before I went and revamped them. I tried to make them more relatable. People still ask me questions like I don't understand, but I get it. Distributed databases can be a tricky thing, and understanding things like consistency models or consistency levels, as we call them, can be. It just is not intuitive in some ways.
Yeah.
Distributed systems and distributed databases are kind of unique.
It seems ironic, doesn't it, that we actually make it a lot easier than another database out there.
Well, you know what? I mean, that's why we have so many customers, particularly, like a lot of Azure services that have to run. They are by definition distributed systems. They run on a cloud and in multiple regions, and that's why so many services in Azure take a dependency on us. Is because we've solved a lot of their hard problems. And made it easier for them. Is it completely friction free? Well, no, there's still some things, but yeah. All right, so some new features you've got here.
So I wanted to show that the support doc showing the features that we support, and just to mention, of course these features actually I'm showing here will if you were to look at that doc and look for them, they would probably be listed as not supported because most of these are in private preview. So I just wanted to call them out. If you are evaluating Cassandra API and you look at that doc and it's certain features not missing, then it might be here. It's always worth asking or reaching out to your account team or your friendly Microsoft person that you're in contact with to find out if we're building something. We're always trying to add more compatibility and of course also unique features that we expose as well. But these things that you see here, materialized views, lightweight transactions with condition support. We already support lightweight transactions, but with conditions, truncate, and also support for GlowRoot, which is an APM tool. These are all in private preview. So if you use GlowRoot or if you use these other features, you should reach out. And if you're evaluating this and that's a missing feature for you, then please do reach out, and we can enable
materialized views. So earlier, something you said caught my ear in that they don't really have support for doing things like aggregates and stuff like that. Is materialized views Apache Cassandra way of getting around kind of limitations of CQL itself? Because it seems like you use those to basically do aggregates that create materialized views out of them. Is that what that's all about?
It's exactly that. Although I would argue that our implementation is going to be more efficient. Maybe I won't go down that road right now, but because it'll take too long to describe it. But yes, that's basically the goal of it. It's actually a feature that was experimental in Cassandra for quite some time. So that kind of tells you something about the difficulties in putting it into Cassandra. But of course, for us, it's more straightforward because we have change feed, and so that's the basis for how we've built materialized views. And we expose it exactly the same way as you expect to see it in Cassandra. So it'll work from a API programmability perspective. But yeah, you should be pleasantly surprised when looking at that.
So I put this URL up for the Cassandra change feed sample. Is that a good place to put that up there? I see you've got your ranges for change feed up there. You want to talk about that, I guess?
Yeah. So there's a couple of, I will these native Cassandra features. They'll be well known to people who know Cassandra. But there's a couple of features we're adding that are unique to Cassandra API. So you wouldn't find this exactly in Apache Cassandra. And one of them is change feed. We already have change feed. We've already exposed change feed in Cassandra. So I guess for people who don't know what change feed is, or maybe you missed Tim's great session that he did with you a few months ago, just very kind of high level. You should definitely check that session out as well, because that will tell you a lot more about how this works. But very high level, any database, if there's data coming into the database, you're going to want some way of persisting it, obviously, and tracking the change log in some way. So the way that we've done this is with a distributed persistent event store, which we call change feed. And there's various analogs for this in different databases. Cassandra calls it a CDC, a change data capture, and other databases will refer to it in a different way. But what we have, which is a little different, is a a programmability model where you can subscribe to changes that happen and then read them and then use that to push data to other targets, and you use it for event sourcing and so on and so forth. And we've exposed this in the CQL language in Cassandra, so you can read it directly from CQL. So it's a query predicate in a CQL query in Cassandra, and basically you run the query and then you keep setting the paging state. Effectively, it's just a query that runs forever, right? Because it's a continuous feed of changes. So that's how that works, and there's obvious uses for that.
That's interesting in there. Yeah. So because it's confusing to me, I guess, at some level, because for change feed in our SQL SDK, it's basically you just set up a delegate that sits there and listens.
Yeah.
And then that fires every second or whatever interval you set, and then more data appears in a collection or an array. How does this work? And do you put this on like a while? Oh, I see it is on a while loop there.
Yeah.
Okay, so this thing just sits there kind of hanging just in its own thread, and then it somehow that acts as a delegate, this CQL, if you will, or this.
Yeah, well, yeah, this is how we've had to expose it. So we're exposing it as though it's a query, but we're actually interacting with the change feed. The reason we're doing it this way, just to kind of expand on what you're touching on there, is of course in SQL API we control the client drivers, so we can control how we interact with the change feed. Yeah. And the programmability model, including things like change feed processor and how we do, partition key ranges and continuation tokens and etc. We don't have the same control, obviously, over the client drivers in Cassandra. So we've exposed it in a different way, and you query the change feed as though you're querying a table, but you're actually interacting with the feed. It's just a never-ending query, so you're constantly updating the paging state to see what is available. Sometimes there's nothing available. If there's a change there, it will be available. So that's how we've exposed that.
That's ingenious, Theo. Whoever came up with that, give them a gold star. That's brilliant, because you're right. You don't have to worry about compat with a driver. You don't have to roll your own driver. Yep. For this thing. It all just works, and you're staying true to the spec, if you will, by just having this special table that you're running a query on. So, okay. Yeah. Very cool. That's man, I'm getting smarter sitting here today. This is great. So
yeah, I'd love to say it was me that thought of that, but it wasn't me. But I agree. It's a very good idea.
It's a great idea. Yeah. I love it.
Yeah. So one of the limitations with that, however, is if your client is querying the gateway, which is what you transforms your requests into what we need at the back end. At the moment, we haven't exposed this as something that can be parallelized. So when you query, when you run this query, the gateway sends requests to all partitions, and we're getting everything back. So if you have hundreds or thousands, maybe, of partitions, then your client is really acting as a bottleneck in that sense. So what we've done to kind of bring this more in line with where SQL API is exposing something which we're calling feed ranges. And these feed ranges, you can think of them like a token that you can use to parallelize querying across the whole change feed. And they represent the whole value space that's possible in a table, if that makes sense. So if I query a feed range, it can still handle splits in the data at the back end. I don't need to be aware of new subsets of feed ranges that appear. So just maybe this will help to illustrate this. If data grows, then we'll add new feed ranges. But they won't actually be new feed ranges. It will just be the same data divided into a larger number of chunks, if that makes sense. Yep. So what I'm saying there is the existing feed ranges will still work. You'll still have the same parallelism as you had before. It's just that there are more feed ranges available. You just have to restart the client to pick them up in this case.
So that's and just to clarify for folks that may be confused. So with change feed actually lives on the physical partition. And so that's why when you see things like the lease container that you cannot do for Cassandra, they've got their gateway, and you need a way to be able to parallelize the consumption of the change feed that's across these feed ranges because they live on different physical partitions. So that's what you're looking at here, if I'm gathering this correctly.
Yep.
Yeah, interesting. Okay, that's an interesting. That's interesting. Now that you guys went and tackled that as well. So okay. Oh, you got a demo.
Yeah, I was going to do a little demo of this. Just
hey, before you do it, I got a question from a viewer, maybe, since we're talking about kind of physical partitions. Can data be physically stored row-based or column-based? Column there in parentheses. On the other hand, we have wide column type of NoSQL databases. It's confusing, the words columnar versus wide column.
Yeah, so this is surprisingly confusing. Cassandra API is a wide column database. It is not a columnar store.
Column store.
Yeah, columnar stores are stored in a manner that you can scan by column, so they're good for aggregates. Cassandra is the complete opposite of that. It's a row-based store, like Mongo or SQL API and so on. It's really geared towards transactions. But sometimes I've heard it referred to as wide column, and then that gets conflated into columnar, which is something completely different. So yeah, it's a wide column or column family, also known database.
Yeah,
and obviously we've implemented it in just the same way.
Yep.
Interesting point though there, which is and we don't have it yet, but eventually, very soon, hopefully, we'll have integration with Synapse Link on Cassandra.
Oh, that's coming.
Yeah, it is coming. I can't say when, but it will come eventually. And of course, as viewers might know, Synapse Link is our way of integrating with the analytics store in Cosmos DB, which is this real-time sync of transactional data from the transactional store to an analytics store that's kind of drip-fed in near real time, so you can query that from a different engine, T-SQL or Spark, and so on. We'll implement it in exactly the same way. And when that happens, that will turn Cassandra API effectively into also a columnar store, right? With the proper meaning of columnar is that you can actually scan by column and you can filter on aggregates, or it's really optimized in that way as opposed to transactions.
And
so you kind of both worlds, I guess.
It is, right? Because you said it was built to be, high volume, fast transactional store for the likes of Facebook and Netflix, and now marry it up with Synapse Link, you're going to get the best in the OLTP space and all the analytics, with it being also automatically ETL'd into a columnar store as well, right?
Yeah. So, and we think this will be fairly big because, as it turns out, Spark is a really Apache Spark is used a lot by the Cassandra community to query their data in Cassandra. And the reason for that is because it's not really very good with aggregations, right, or analytic style queries. So if you want to do anything like that, you kind of have to either pull it out somewhere else or use some other kind of engine. So the community built a Cassandra Spark connector. And so a lot of folks are using Spark, but the problem with that is that exactly the problem that we've solved with Synapse Link is that you're still querying against your database, right? So if you're just running a bunch of Spark queries, it's going to kill the throughput available.
That's us making things easy again.
Yeah.
Darn Cosmos guys.
Yeah.
All right, what do you got here? Let's see what this is your change feed.
Yeah, so this is a sample, and this is I think this is probably the sample that you linked before. Let me just show it here anyway. This is really hot off the press. Let me just say that right now. So we've even got a little warning down here to say this feed ranges is in private preview. So please reach out if you want to have that enabled on your account. You can have a look at this sample. And what this sample is doing is kind of putting into effect what we were showing before. So there's actually a lot of stuff in here. So I won't talk about it all, but I'll just pick the main points, which is it will create a table within your key space called change feed page state. So all that will do is just persist the paging state for each feed range, and then the first time it runs, it will pick up all of the current feed ranges available in that table, and then it will, based on what you specify in your concurrency settings. So I've got a concurrency of 10 here. If you can specify less than the number of feed ranges you have, if you do, then it will just divide all of the feed ranges among your threads, and then each thread will just kind of execute on a round robin, as it were. But you can't have more concurrency than you have feed ranges. So the number of feed ranges available is the maximum concurrency that you'll get here.
Yep.
So let me just run this thing quickly and just see what happens. So that's going to run here. It's actually not doing very much. It's just, when it sees a record, it will just process that, and it's saying there rows available 0, and you can see I've got here 0, 1, 2. So I've got 3 threads here. If I was to do maybe let's try this. Didn't try this earlier, so I've not prepared myself. Let's take a risk. I do a little update on my table that I'm kind of listening to on here. I should be able to hopefully see the update. So let me just do a little update on a table.
You can hide that tray if you want. That's good.
Yeah. And do I see that update? Did I see it, or did I miss it already? Yeah, there you go. There it is.
Yeah, row available. There you are.
Yeah. So yeah. Anyway, there's 3 threads running here. So you can see there I specified 10, but I've only got 3. And what does that mean? Well, that must mean that I only have in my
partitions.
Yeah, I've only got 3 feed ranges.
Yeah.
Now, what I didn't show before is in this sample here. Well, I think maybe I did show it before. I didn't really talk about it much. So it's fetching the current feed ranges, and what it will do is execute this little query here, and this is what we've exposed effectively. So all of that you've just seen is just internal management inside this sample. But this is what we've exposed. This is a virtual table that you can have access to, and this will
I see.
Yeah, return back the feed ranges that are available to your table.
Very tricky. So your filter predicate is actually the from. If the from is this virtual thing, and then you basically are selling it, use the where clause for the key space name in the table.
Exactly. Yeah.
Very tricky.
Yeah.
I like this.
Yeah, and then so we get that back, and if I can go and query this here as well. Now I see that when I query, I actually have 4 feed ranges here. So you can see that it's running with the set of feed ranges that I had before, absolutely fine. And but you'll have to trust me. There's processing all of the data that is available with just the previous feed ranges. But I've obviously, either the data's grown or I've scaled up in the meantime. Well, I know what I did. I scaled up. Okay, so I scaled up to enough request units that it will give me 4 physical partitions. So if I was to just stop this thing here and then delete my page state kind of maintenance table here, and then if I was to start this up again, it should then pick up whatever feed ranges are available at that time. So let me just, I'm sure that will delete eventually. So let me just start this thing again here. And what we should see, hopefully, is, well, yeah, four threads, right? Yeah, and there we go. So 0, 1, 2, 3. That's 4 in total.
Yep.
And it should have picked up. It should have created a new version of that table.
There we go.
With the 4 feed ranges in here.
Got it. Yep.
So that's how that's working. Now, obviously, it's not automatically picking up the new feed ranges. But to be honest, if you have a really large, let's say you have a really large, container or table, you have you set it at a certain level, a certain point in time with 10 or 20 or whatever feed ranges. That's gonna be a lot more scale than you would have had previously. So if you're dealing with hundreds or even thousands of partitions, we certainly have customers who are doing very, very big volumes with this thing. You could change the concurrency on a processing change feed by 60 or 100x straight away. Over time, we'll develop this so that we implement splitting and merging of continuation tokens within the feed ranges, so that we can then automatically increase the number of feed ranges that we implement on the client side, or that you can implement on the client side. So we'll expose like something like a system function at the back end that will allow you to do that.
Is that so? That's really interesting. Like today, if you wanted to do something like an auto scale for change feed, you would need to use the change feed estimator to figure out what is your latency in terms of picking up changes. And then you would scale it up and down based upon how far behind you're falling. You're saying you're going to make that even easier, though. The customers wouldn't need to they wouldn't need to implement that.
Well, no, we're gonna make it equivalent to what SQL API does now in its implementation on change feed processor within functions and how that's integrated. That uses the estimator automatically. Mm-hmm. We're going to bring it in line with that capability. There'll still be probably a little more hand cranking that you'd have to do as the developer on the client side, because obviously we can't control everything there, right? So we'll have to play some tricks like we've already done with the CQL predicate and so on. But certainly from the capability, you'll be able to implement it in such a way that it will scale automatically as new feed ranges, a new subset of feed ranges are available, and incorporate that into the processing. But to be honest, even with this, it's light years ahead of what you might have in native Cassandra, for example, because there's nothing like this programming model to be latest contribution to the Cassandra ecosystem.
Are they a pretty open, friendly ecosystem? I'm just curious if.
Yeah, I think so. From what I've seen so far, to be honest, until recently, till we've started playing around with managed instance and so on, we haven't had that much interaction with the community, because it's always been we've got Cassandra API, and we build that to the wire protocol, and everything else is we make sure that we're compliant with what is expected of the client side, but Cassandra API is Cosmos DB. It's all completely separate. But now that we are actually running a service that is pure Apache Cassandra at the back end, and we're developing things that will help that work better, and obviously it will also help other versions of Cassandra as well. Then we're sort of we're only just starting to get into the community in one sense for the past probably 6 or 12 months. Really,
makes sense. Yeah, that makes sense. Yeah, and I know I titled this episode about Cassandra Api, but this has been good just talking about all of these other things about the our own Cassandra API. Implementation as well. So
I feel like I hijacked it a little bit to talk about
Cassandra. That's okay. That's okay.
So we'll talk about MI as well, definitely. But yeah, the other feature, this is actually in production now. At the time I was putting this together, I didn't know if we were going to be there, but it's actually in production. It's not documented yet. But if you know about MongoDB API, or if you've seen any of the stuff on that, you might know about this already. So this is server-side retries. Just to give some context on what this is and why we have needed to have it, I should probably set some groundwork on request units. So viewers might know request units is how Cosmos DB provisions capacity. So request units express capacity in terms of requests per second. So if you know the cost of a request and you know your workloads, you know how many reads and writes you have and what each one of them costs, you can be really deterministic about provisioning, which is awesome, right? It's, if you can really go to town on profiling what your workload looks like, and it's you can be very efficient in how you provision that. The downside of it is if you don't know your workload on the other side, and then you exceed capacity, you get what we call rate limited, which can be a little frustrating. Now, of course, SQL API. We build all of the SDKs, so the SDKs intrinsically know about rate limiting, and they have intelligent retry mechanisms and so on all across the board. But again, it's kind of similar to the last feature in Cassandra. We don't have that control, right? So the out-of-box drivers don't know anything about rate limiting. So what we did or have done is publish things like extensions for Java, and your customer user has to implement them to make sure that it's retrying properly and all of that. But obviously, they'll work differently for different drivers, and that can be a bit cumbersome. And meanwhile, if you didn't implement it, then you might just hit this rate limiting problem. So in the end, what we've done is just the same as what MongoDB has done. And just for those of you, new to rate limiting, or maybe new to Cosmos DB, or just to kind of illustrate the kind of problem that you run into here, let me just, and again, just show a really simple app here. So this little app is just, all it's doing is just shoving a bunch of records into a table, and this table happens to be provisioned with only 400 request units. So 100 writes per second is going to overload that table. And to begin with, I'm just going to bash it against a table that doesn't have server-side retries enabled. So let's just see what happens when we do that. I think you can guess what's going to happen. Yeah, so it'll work for a short while, and then straight away you're going to get these. And this is what we're contending with. The driver doesn't know anything, despite the fact that Cassandra, unlike a lot of databases, it has client drivers that do have retry policies that you can define, but of course it doesn't know the circumstance in which you might want to retry for something like rate limiting, because it was obviously not designed for that. So what I'm going to do now is just switch over to my other account here that does have SSR enabled, and let's see what happens when I run this thing again. Hopefully it will be a little bit better. So you can see that everything's now. There's a bit of latency there, obviously, because these requests are being retried at the server side as opposed to on the client, which means this will work for any driver. It doesn't matter what you're using. But I guess what this does is just kind of makes it behave a little bit more like a normal traditional database, right?
More like a VM hosted Cassandra, basically, right? Yeah, requests are just going to queue up until the CPU can, or the dispatcher can get to them, and then execute them and return. So we're basically making it feel the same way, because we're not running on a VM. We're resource governed. So you get up to what throughput we give you, or you provision, and no more, right? So that's this is great. This makes a lot of sense to do for this, and obviously for like Mongo too.
In case anyone wants to know how to enable it, it's exactly the same as MongoDB. You've got this property here, and you just enable it.
And that's free, right? They don't charge for this.
That's free. It doesn't. It won't. I should point out, it doesn't retry indefinitely, obviously. So like you said, we're a resource-governed database. So if we were retrying indefinitely, then we would, it would be quite difficult to manage that. So we retry up to 60 seconds worth of retries, and then we'll time out. But in most cases, if you're waiting 60 seconds for a response, then it's probably too slow for you anyway. So it just kind of takes away the headache and the anxiety of having to deal with that. And I guess you're getting a little bit of both worlds. Then you're getting the deterministic sort of request unit currency that we've got in Cosmos DB, which is very much in line with the kind of PaaS services that provide that kind of thing. But also, you've got this behavior that's a little bit more traditional and something that you're more used to.
Yeah. Cool. What's next? Oh, talk about Cassandra MI. Oh, you had a link here. This elastic scale. Is this your server side retry?
Yeah, that would be, so that's that. Yeah, that you just take a look at that, and those are all of the kind of options around scaling in Cassandra, and it mentions about rate limiting and how to handle that. And obviously, like I said, we haven't documented this yet, but we think that this is going to be a big improvement. There'll still be some situations where you might want to have your own retry policy at the client side. So, like for example, I don't know, maybe you want some requests to fail and stop because you don't want them taking up resource that other systems or other processes are more valuable for, or something like that. I don't know. In which case, you would need to have different policies, I guess, for those different clients. Bear in mind, server-side retry applies across the whole account.
Yeah.
So, there might be some scenarios, but to be honest, in most cases, I think most people just want to switch this on.
I would think you'd almost that most customers would immediately turn that on. It seems like.
Yeah, I think so. Yeah, certainly what we've seen in Mongo. Yeah.
So let's talk about Cassandra MI.
Yeah, finally talking about Cassandra MI.
This has been a great episode. You've covered so much cool stuff, and like I said, we've never talked about Cassandra on here. And there's a lot of stuff I don't even know, so I'm learning a ton, and I'm sure our viewers are too. So this is great.
Yeah, so Cassandra MI, Cassandra Managed Instance. I guess it makes sense to I've kind of put this as how to choose, but I guess it makes sense to talk about where we came from and why it was built. So I guess, I mean, if you are somebody who a company or a customer or a user who uses Cassandra today, and you're wanting to move to the cloud, any cloud from on premises, let's say, then you kind of are facing with two choices. Either you've got something like a Cassandra API, a cloud native version of Cassandra. There's others out there, but we were the first, so I'm just putting us up there. But yeah, you've got something like that, or you've got lift and shift, basically. So you're running your own VMs in Azure or some other cloud, or maybe you'll self-host something like DataStax or something like that. So what we've added is this thing called Azure Managed Instance for Apache Cassandra. And where this came from, one of the sort of first earliest signals that we got for this was that people were talking to us about Cassandra API, and they were saying, yeah, I want to use it. I'm on premises. How can I connect Cassandra API to my cluster, right? How can I do bidirectional replication? And of course, the answer to that was, well, we can't do that because that would mean that we'd need to implement Cassandra's gossip protocol, its internal protocol for replicating data between nodes within a data center and within a cluster. And this ask came up quite often, surprisingly. And so what we were seeing was that although some customers, obviously, we have plenty of customers, but there were customers that were wanting to use Cassandra API, but they're not, for whatever reason, quite ready to completely dive into it. Or they kind of wanted to use it as an extension of their existing environment, right? For whatever reason. So this was interesting, and for various other reasons as well. We were seeing that there were, there's a gap between being on premise and using Cassandra and being really invested into the platform, because it's a very platform oriented database, right? You get into the back end aspects of it. There's a big gap between being in that space and moving to Cassandra API, even though Cassandra API has a wire protocol. We've made it as compatible as we can, and to lower the friction if you want to move to something like Cosmos DB. There's still this gap between the two, and what we like being able to deploy a hybrid cluster. I guess they say that what's the saying? A necessity is the birth of innovation, is it? So, when you need to do something, it produces things that you have to innovate on. And we realized that we were going to need to do this in some scenarios or to meet certain customer demand. It turns out it's not been done before, or at least certainly not for a Cassandra managed service. or any other type of managed service, as far as I can tell. This is where you have a managed service, but you're allowing it to connect in some way to make a kind of heterogeneous environment out of a self-managed version of that database, or self-managed component of that database, and the managed component. So in this case, you have a cluster that is formed of a data center or many data centers in Azure Managed Instance for Cassandra, and a self-hosted data center. And the two are kind of merged together and connected together via networking and via sharing certificates and seed nodes that represent the core nodes within a given data center. And that's what we've provided for this service. And that has two things. One, it answers that initial question that we were getting for customers, but it also makes it a lot easier to migrate. As it turns out, we can't build a better migration tool than Cassandra itself.
Because it's replication technology.
Yeah, the replication is obviously very seamless. And when you have this capability to add data centers into a cluster ring, and you inject those resources into a virtual network, which is what we do with the managed service, that allows you to connect it to anywhere else that you want, and effectively you can create a hybrid cluster. So that's what we've built in there.
The gossip protocol, do you go back to that slide? So how does that require some special networking? I mean, can I do this over public internet, or do I need some kind of private network to do this, or?
It doesn't require special networking. It runs on a certain port, but with Managed Instance, the one thing that we do insist on is that your existing data center or cluster that you want to configure a hybrid cluster with has to implement TLS, has to implement certificates, node-to-node encryption, it's referred to.
I see.
So that's the one thing that we insist on. But aside from that, I mean, the networking to do this for on-premise would be typically something like ExpressRoute, and then virtual networks paired between any additional data centers that you have in Managed Instance, or just using ExpressRoute to do you make a circuit between
your on-prem
we have in the cloud or on-prem as well. Either way, it is fine as long as there's a clear route through back and forth between the different resources. Then it's just a matter of sharing certificates and defining the seed nodes in each environment. So we provide the mechanism of doing that. As I said, there's no other managed service for Cassandra that's allowing folks to do this. So we'll see how that goes.
That's cool, right? We're being a first in that regard. Yeah. I mean, I could see how this could make migration for existing Cassandra users that are managing clusters of Cassandra so much easier.
Well, yeah, I mean, I posted it the other day. It is the most, I mean, technically it is the most seamless way of migrating an on-premise, let's say, Apache Cassandra cluster to a managed service in the cloud. I can't see any more seamless way than using Cassandra replication to do it. So yeah, there were the caveats of it. I mean, we'll come to that later on, but you have to be running something that's compatible with what we support. But aside from that, if you are, then it's really super straightforward to get your environment up and running in the cloud, or even just run it as a hybrid cluster for a while. That will be seamless as well. And then once you're happy, you just decommission what you have running on premises there.
Now, when you do our Cassandra MI, I'm guessing you can create multiple nodes, so you can have that fault tolerance as well. Is that correct?
Yeah. So you need to have at least 3 nodes in any given data center for a quorum, and typically we say you should have an odd number of nodes for the same reasons that we do that in Cosmos DB.
Okay.
Yeah. So. Well, I mean, I guess what we envision here, and certainly based on the evidence of what we've seen from talking to customers, is that most customers who are using Cassandra on premises they might want to use Cassandra API or something like Cassandra API, but they're probably going to want to do this, right? They're going to want to lift and shift And it's going to be very interesting to be able to lift and shift so seamlessly into something that's managed and does things, a large percentage of things for them. And then we see maybe later on they might want to take advantage of Cassandra API, and maybe they'll even migrate fully into Cassandra API. But they don't have to. They could just stay here, or they might even stay here. It's really up to the user, the customer, to decide what they want to do. We haven't built this with a view that everybody's going to eventually decide to use Cassandra API or Cosmos DB. It's really, it's a standalone product. Obviously, we got the experience of how to run distributed databases. And we've got the experience of talking to Cassandra customers who want to get into the cloud. They want it to be managed and easier. But we've learned that, it's not quite so simple as just giving them a wire protocol compatible version of Cosmos DB. Like I said, if their starting point is, they're really invested in Cassandra, there's quite a big gap between that control that you see there on the left-hand side and the productivity that you might want to get to with something like Cassandra API. And from the perspective of some folks, depending on their workloads, they might be giving up too much in that case. So really, we're going to just see how this thing goes. If it becomes popular, then it becomes popular. If it acts as a stepping stone, then that's fine as well. And like all of these things that I've listed here, I'm not going to read them all out, but basically they kind of collapse down into this. This is what Scott Hanselman, this is the kind of analogy that he gave last time I was on Azure Friday. I really liked it because it really just describes the situation, right? If you're talking about the platform itself in terms of running the database platform, Cassandra API is really like an Uber. It's doing everything, right? We're running the clusters. We are maintaining everything. We're doing patching. We're doing all of that. All you're concerned about is creating key spaces and tables and schema and the application side, right? At the other end of the spectrum, if you're self-hosting, you're going through the gears yourself. And then managed instance is like an auto shift, right? You're still in control. You're still driving, if you want to think of it that way. And actually, where we're going with this is going to be more like a semi-auto shift, right? So we're going to give as much control as possible so you can shift through all of the gears. In other words, we'll do a bunch of automation. So we'll automate deployments, automate scaling up and scaling down of nodes, automate operating system patching, security patching for Cassandra, running Reaper to do auto repairs on different nodes and so on, and various other things. But you'll be able to override all of it potentially, like you can in a semi-auto shift, right? You do the paddles on the steering wheel. We won't give everything. You can think of it like the clutch, I guess. We won't let you we'll still be maintaining the operating system, and that will be locked down. But from the Cassandra level upwards, the intention is eventually, certainly by the time the service is GA, to give you the complete control over everything. If you want to override it, if you don't see the need to override it, you can let us do it, and it's really the choice is up to the customer.
Yeah. That's cool. I mean, that's, if you're sick of managing clusters, then why not go with just letting us do everything, right? Or just touch the things you absolutely need to touch. And so I love it. And Scott does a great job.
Yeah, it's really good with analogies. Yeah. Yeah, so I'm going to continue to steal that. Yeah. So, I mean, I just talk very quickly about how to migrate. So what's happening here? Okay. Yeah, so like I already said before, we've now got by far the easiest, most seamless option for migrating. If you're running on-premise with Cassandra and you want to get into the cloud with some kind of managed service, it doesn't get more seamless and more straightforward than this, really. If you happen to be running a version of Cassandra that we support, version 3.11 or higher, or close to 3.11, even if you're running data stacks and the underlying Cassandra version matches or is close enough, it's going to be possible at least for you to do this. And then once it's all set up, it's really, as I said, there's no better tool than the database itself. for replicating itself to other environments. If that's not possible for whatever reason, maybe the version doesn't match, or maybe you're running some other Y protocol compatible cloud service other than Cassandra API, don't want to mention any names, then you could use the dual rights approach. So we've documented this already. We did a video on Azure Friday. You want to go and check that out. This process, the approach to this has been around for a while. People have been doing dual rights to achieve migration for a while, especially if there's not much data, historic data, or any historic data to move. Obviously, it's straightforward to just get your app to write to two places. But we've made this a little bit more straightforward by just lowering the friction on the app side. So we created this dual write proxy that you install on your source cluster, and it runs on a different port. And you install it on all the nodes, and then you just connect your application, point it to a different port, and the proxy will forward all of your rights to your target. So it just reduces the friction having to make changes all over the place on the app side. And so that's all documented, and you definitely check that out. To be totally transparent, it in theory it works for any form of Cassandra, including Cassandra API, if that's your source. So maybe I should have lowballed that really, but anyway, we're in the open source community now, so you have to,
If you want to go from Uber to automatic, I guess you can.
Well, yeah, or manual. It's
manual.
Entirely up to you. Yeah. And then, there's offline options. So we recommend Spark. It's especially with Databricks and Azure or some service like that. It's very straightforward for offline migrations and very scalable. And we've documented the approaches to that as well. So I wanted to do a little bit of a Blue Peter style demo. I don't know if do you know what Blue Peter is?
No.
I guess it's not very famous over there. It's a British TV show, which is famous for people. It's a children's TV show where they do demos of things, or they do arts and crafts and things. And they were famous for always saying, "And here's one I made earlier." So that's what I mean by
the only TV shows I know. I don't know why, but my son seems to love the ones coming out of Australia. So Peppa Pig. His new favorite is Bluey out of Australia. I don't know what it is with my son and Australian TV shows, but I haven't seen that one. So I'll have to check out.
Check it out. It's still on.
Okay.
Going. It's been there since the 50s. So,
okay.
So anyway, here's one I made earlier. Here's a hybrid cluster that I made earlier. And what this is, so as you might expect, I mean, obviously it would have been a bit difficult for me to do this on premises and show it easily. So I've just installed a vanilla Cassandra cluster on VMs in Azure in a particular region. So you can see I've installed this in West US 2, and I have 3 nodes installed on VMs, and I also have Cassandra Managed Instance cluster resource. I'll explain a little bit more about that in a minute, but for now, I just want to run this node status command. This is from my source self-hosted cluster node. And you can see there I've got a data center here. That's my self-hosted data center. And down here is my managed instance data center. And some typical thing that you might want to do if you set this up is that you might want to use your managed instance cluster for adding additional capacity, right? And the reason that you might want to do that is because normally on Cassandra, if you wanted to increase the number of nodes in your data center, you'd have to be going and, grabbing some more VMs and installing the software and making sure that you run the right node tool commands to make sure that node comes up properly within the ring and tokens are distributed and so on. But in this service, it's just a CLI command, right? So I'm just going to run this command, and I'm going to scale up the number of nodes here from 3 to 5. Not found. Live demos. What's going on here? Oh, I'm in the wrong window. That's why. So this is, I'm actually connected to my self-hosted node there. So it's not thing that an AZ command is not going to work there. So let me just paste this in here. Okay, so I'm just scaling up my managed instance data center from 3 nodes to 5. So while that's going on, let me just go back in here and let's take a look around here. So like I was saying before, yeah, I've got my VMs here, but I've also got this. Let me refresh this here. There we go. Yeah, so my cluster resources here, and so what happened? The way you do this to set up a hybrid cluster, I have my existing Cassandra cluster. When I want to set up a hybrid cluster, I create a managed instance cluster with the same name, and I provide that cluster with the TLS certificates of my nodes that should have had node-to-node encryption enabled, and also the seed nodes as well. So the nodes within that data center, and then I create a data center, and then I do the same thing in reverse. I give my certificates to my existing, add that to the trust of my existing environment, and I also add the seed nodes there, and that's it. Well, as long as you have the networking set up, that's all you have to do, and then you've got a hybrid cluster. And then what that ends up with is you don't see the resources in here because we manage these. You can see them; they're visible inside the VNet. So we inject the NICs of the nodes that we provision into the VNet. But you don't see the resources in the kind of traditional way because they're hidden. They're in a different tenant, but we're providing the interface cards so that they can communicate with anything inside your virtual network. So that's kind of how that works. Right now, the display, the service is still in public preview. So this will what you see in the cluster is still fairly basic. This is going to improve. There's going to be more information that you can see about your cluster and drill down into nodes and things like that.
Like nodes and stuff. Yeah. That's what I was going to wonder. It's like, where do I see nodes?
Yeah. So the only place you can see them is in the VNet that you can view the injected NICs. But they're part of that, and that's the data center name that you see there. You can see everything that you need from CLI commands right now. It's very CLI heavy.
Just use CLI and do a get on there, right? I think most people that, well, I don't know. I'm presuming most people that manage clusters for Cassandra are probably used to dealing with things in a shell.
Yeah, exactly. So, well, I'm going to do that right now. So let's while this was running. What's going on here? Okay, so this is okay. This is still running. Well, that's okay. I can do this in a different. Let me fire up a different window here. And while that is scaling up, I mean, there's a bunch of commands here, but you just mentioned do a get. So let's try getting the node status of the cluster. And something to point out, what I did with my sort of initial node here. Let me go back to the original command that I was running. The node tool command to get status is going to tell me everything about the cluster. But when I run this from CLI, it will only give me information about the data centers that I have provisioned in managed instance. So to get the full status of your on-premise resources, you'd have to run node tool from your on-premise environment. But so let me just run this and see what that comes back with. This is where I'd normally be editing to make it run faster, but I have to sit here and wait for it to.
Yeah, it's like as the control plane PM, I'm used to my demos running painfully slow because because ARM itself. I mean, just doing these types of operations always takes time. So there's no latency SLA on these things. So.
Yeah, I guess what we should be seeing right now, at some point at least, is. No, we're not seeing it yet. I mean, this can take a variable amount of time. Yep. So, I mean, we should at least see that scale sets are kind of spinning up. So you can see some more. This is the way scale. So don't be alarmed when you see more nodes than you expected. This is the way scale sets works. It has to provision a number of different addresses before it decides on the ones that you wanted. As crazy as that sounds. But hey, we're using scale sets in this service, so that's what that's doing. But yeah, eventually This is going to add nodes to the cluster and then add nodes to the ring, and then we should be able to see this in here eventually. So maybe we should.
Either way, that's pretty simple. Just one line CLI, update the number of nodes, and hit enter. I mean,
yeah,
pretty straightforward.
So this is my node status command. So this is telling me what nodes are available in the cluster, and right now it's saying there's only 3. So that is obviously that scale up command is not finished doing its stuff yet. So it's telling me these are the nodes that are available and running normally. So for whatever reason, this is running slower than I was hoping. So maybe we can.
Yeah, that's live demos for you. It's
okay. Yeah. Yeah, but it does work anyway.
Yeah,
so. Just not for me today.
Very cool.
Okay. Yeah, so that was it, Maria. I just, a little. Here's one I made earlier. Like I said, we've documented all of this: how to set up a hybrid cluster, how to set up multi-region with your managed instance, how to run CLI commands, and there's all the kind of things that you would expect in there. And then the migration stuff that I talked about as well with the dual write proxy is all here, and the Spark offline approach as well. So yeah, there's a bunch of stuff to investigate there. It's developing. It's still in preview, but we're seeing a lot of interest from folks as we expected because of the feedback that we were getting while we just had Cassandra API. So yeah, I'm pretty confident that when this goes GA, we'll be busy. Yeah.
Well, this is awesome, Theo. I can't believe we're like well over an hour into our show here, and it's just there's so much stuff you guys have going on. You got to promise to come back when you push more stuff out or get more of these things released.
Oh, definitely. I'll definitely be back when this is GA. I'll be yeah.
Come on back, and then then next year too, when I saw all that stuff for FY22 on their materialized views and all that other stuff, the named indexes, I can't remember all that other stuff, but you have a lot coming next year. So definitely come on back. I want to learn more. So,
yeah, awesome.
Cool.
Yeah, thanks, Mark.
Yeah, well, thank you very much, Theo. Good having you on. Thank you, everyone, for joining us this week. I hope you enjoyed learning about our Cassandra API and also Cassandra managed. Oh, no. Let me get it right. Managed instance for Apache Cassandra. Is that it? Did I get it right?
Yeah. Yeah.
All right. I gotta stay on brand, or marketing's gonna come find me. So.
Actually, Azure Managed Instance for Apache Cassandra.
Oh, okay. Oh, yeah. I forgot the Azure part. So, oops. All right. Well, thanks for correcting me.
Oh, there we go. It finally finished. Did it
go?
Have we got time to see if it actually?
Yeah, sure.
I want a successful demo. Well, it's finished adding. So it does this asynchrony. So it's finished adding the nodes, but it will take some more time to add those nodes to the ring. So
I'm guessing they have to.
There we go. There we go. Finally, one of them is joining. You see, that was joining.
Ah, okay. Okay. So I'm guessing it has to provision the resource, the data has to backfill, and then it has to complete the final step in joining the ring there. So it's
got it. Yeah, exactly. Yeah.
That makes sense.
Believe me, this is a lot quicker than doing it yourself.
Yeah.
So, yeah.
Way easier too.
Yeah. Oh, there you go. Now you got 4 nodes. So.
There we go. Cool.
Anyway, I won't make you wait for the rest.
No, that's cool. It's all right. Thank you very much. And thank you, everyone, for joining us this week. Just some announcements kind of rounded out. Last night, we had our very first global Azure Cosmos DB user group meetup. We had, I think, a little bit of technical issues there. But if you missed it and want to check it out, we've got a recording. Just head to the link here and then look for our meetup. And then you can find the link to the recording in the discussion down in the comments for our meetup last night. We don't have our next month's scheduled yet, but we're going to get there here pretty soon. So keep coming back and joining us and join our user group up around Meetup, and then come hang out and watch our monthly user groups. I'm going to try to do giveaways for our little neoprene Cosmos DB drink coaster and a little Cosmos DB sticker as well. We're trying to successfully do that next time for our user group. Also coming next week, it's almost here, Azure Serverless Conf, September 29th through the 30th. We'll have three-hour live streams starting 9 a.m. on Thursday, the 29th. Is that Thursday? I can't remember if it's Thursday. I think it's Thursday the 29th. Whatever it is, the 29th, 9 a.m. We'll kick it off. And then later on that evening, at least evening Pacific time or evening U.S. time, afternoon Australia time, we'll have the APAC stream. And then after that, we'll have the EMEA live stream. So come check that out. We'll have sessions live for you, unique sessions for each of the 3 live streams, wherever you are in the world. Take some time and come and watch community and see what they're doing, building serverless event-driven applications using Azure Serverless technology. So come check that out. We'll have lots of live or on-demand sessions available too. Got any show ideas? Drop us a line at Azure Cosmos DB on Twitter. Always interested to see if anybody has any interesting show ideas. Next week, we're going to have Andrew Liu back. And we're going to finish the conversation we started back on episode 20, which was, gosh, about 6 weeks ago now, because this is episode 26. And he's going to go into details on the things we kind of touched on, like our gateway and how that works, and how our query engine works, and how kind of the quorum mechanics works for our replica sets, both locally and then also talk about replication as well. Our compute layer, indexing, more change feed, all kinds of stuff. So we'll have him available next week, and come and check that out. Ask lots of questions. It's always great to have him on. I think he's basically a founding member of the team, nearly from a PM perspective. So he knows lots of stuff, and so you can ask all your questions. So that's it for us this week. Theo, thank you very much, sir. It was great having you on.
Pleasure.
And okay, folks, thank you. We'll see you next week.